In mathematics, a paraboloid is a quadric surface of special kind. There are two kinds of paraboloids, elliptic and hyperbolic. The elliptic paraboloid is shaped like an oval cup and can have a maximum or minimum point in a suitable coordinate system with three axes, and it can be represented by the equation where and are constants that dictate the level of curvature in the and planes respectively. This is an elliptic paraboloid which opens upward for c greater than 0 and downward for co. This is a hyperbolic paraboloid that opens down along the x-axis and up along the y-axis. Properties. With A equals B, an elliptic paraboloid is a paraboloid of revolution, a surface obtained by revolving a parabola around its axis. It is the shape of the parabolic reflectors used in mirrors, antenna dishes, and the like, and is also the shape of the surface of a rotating liquid, a principle used in liquid mirror telescopes and in making solid telescope mirrors. This shape is also called a circular paraboloid. There is a point called the focus on the axis of a circular paraboloid such that, if the paraboloid is a mirror, light from a point source at the focus is reflected into a parallel beam, parallel to the axis of the paraboloid. This also works the other way around. A parallel beam of light incident on the paraboloid parallel to its axis is concentrated at the focal point. This applies also for other waves, hence parabolic antennas. For a geometrical proof, click here. The hyperbolic paraboloid is a doubly ruled surface. It contains two families of mutually skew lines. The lines in each family are parallel to a common plane, but not to each other. Curvature. The elliptic paraboloid, parametrized simply as has Gaussian curvature and mean curvature, which are both always positive, have their maximum at the origin, become smaller as a point on the surface moves further away from the origin, and tend asymptotically to zero as the said point moves infinitely away from the origin. The hyperbolic paraboloid, when parametrized as has Gaussian curvature and mean curvature. Multiplication table. If the hyperbolic paraboloid is rotated by an angle of I/4 in the plus z direction, the result is the surface. And if then this simplifies to finally, letting, we see that the hyperbolic paraboloid is congruent to the surface, which can be thought of as the geometric representation of a multiplication table. The two paraboloidal functions and are harmonic conjugates, and together form the analytic function, which is the analytic continuation of the parabolic function. Dimensions of a paraboloidal dish. The dimensions of a symmetrical paraboloidal dish are related by the equation, where is the focal length, is the depth of the dish, and is the radius of the rim. Of course, they must all be in the same units. If two of these three quantities are known, this equation can be used to calculate the third. A more complex calculation is needed to find the diameter of the dish measured along its surface. This is sometimes called the linear diameter, and equals the diameter of a flat, circular sheet of material, usually metal, which is the right size to be cut and bent to make the dish. Two intermediate results are useful in the calculation, or the equivalent, and where and are defined as above. The diameter of the dish, measured along the surface, is then given by where means the natural logarithm of, that is its logarithm to base e. The volume of the dish, the amount of liquid it could hold if the rim were horizontal and the vertex at the bottom, is given by where the symbols are defined as above. This can be compared with the formulae for the volumes of a cylinder or a hemisphere where and a cone of course, is the aperture area of the dish, the area enclosed by the rim, which is proportional to the amount of sunlight a reflector dish can intercept. The surface area of a parabolic dish can be found using the area formula for a surface of revolution which gives. Applications. Paraboloidal mirrors are frequently used to bring parallel light to a point focus, for example in astronomical telescopes, or to collimate light that has originated from a source at the focus into a parallel beam, for example in a searchlight. The top surface of a fluid in an open-topped rotating container will form a paraboloid. This property can be used to make a liquid mirror telescope with a rotating pool of a reflective liquid, such as mercury, for the primary mirror. The same technique is used to make solid paraboloids. in rotating furnaces. The widely sold fried snack food Pringles potato crisps resemble a truncated hyperbolic paraboloid. The distinctive shape of these crisps allows them to be stacked in sturdy tubular containers, fulfilling a design goal that they break less easily than other types of crisp. Examples in architecture: Commonwealth Institute, in Kensington, London; St. Mary's Cathedral, Tokyo, Cathedral of St. Mary of the Assumption, San Francisco, California; Saddledome in Calgary, Alberta, Canada; London Villa Park, Wrexham Swimming Baths, Wales. See also: ellipsoid, holophones, hyperboloid, hyperboloid structure, parabola, parabolic reflector, quadratic form, rotation of axes, saddle point, saddle roof, translation of axes. References